Let's start with question 5. We have x squared minus 2x equals 12, and we need to figure out the value of x. So our first step is to find a perfect square for which x squared and negative 2x are the a and b term. So I know that to find my binomial, I simply need to split my b term, which is negative 2, in half, and I'll have negative 1 in both of my binomials. X minus 1 times x minus 1 is, of course, the same thing as x minus 1 squared. Once I've found my perfect square in factored form, I'll find my perfect square in standard form by multiplying each of the terms in my factored form. Remember that every single term needs to be multiplied by every single term. It's easiest for me if I take the first term in my first binomial x, and I multiply it times both terms in my second binomial. I end up with x squared minus 1x. And then I'll take the second term in my first binomial and multiply it times both terms in my second binomial for minus 1x plus 1. And I can simplify by combining my like terms for x squared minus 2x plus 1. A few things to notice here. First is that we ended up with the same a and b term, x squared minus 2x, x squared minus 2x, as our original equation. We have a c term of plus 1, which we'll deal with in a second. But let's also take a second to note that the perfect square in factored form, x minus 1 times x minus 1, which we decided on because minus 1 is half of negative 2, is the equivalent expression to x squared minus 2x plus 1. In other words, x minus 1 squared equals x squared minus 2x plus 1. Because all we did was factor x minus 1 times x minus 1. So now we'll return to our original equation. We have x squared minus 2x equals 12. And we want to add that 1 into our original equation. But remember that whatever we do on the left side of an equation, we need to do on the right. So I'm going to add 1 to both sides. Now, notice that I have my perfect square in standard form, x squared minus 2x plus 1, which you also see here and here, in my original equation, which means I can convert it to factored form. So I'll rewrite my equation as x minus 1 squared equals 13, because I added 12 plus 1. Now, this was really the whole purpose of all the work we did on the left, because now we only have a single x in our equation, which means we can find out its value. I need to get rid of my squared on x minus 1 by taking the square root of the left. If I take the square root on the left, I do it on the right, and I end up with x minus 1 equals the positive or negative square root of 13. Notice that I left 13 under the square root symbol because the square root of 13 is not a whole number. I also included a plus or minus sign because the square root of 13 could be positive or negative. My last step is to add 1 to both sides, and I end up with 1 plus or minus the square root of 13. If you typed your original equation into a calculator, 1 plus the square root of 13 minus 2 times 1 plus the square root of 13, your final answer would be 12. This x value is the solution to our original equation. Let's move on to 6. And I'm going to do part of the problem for you to get you started, but hopefully you feel comfortable doing a little bit more of this one on your own. In question 6, we have 1/2 r squared minus 6r equals 2. Remember that when we have a coefficient on our a term, we need to factor it out. If we put 1/2 on the outside, we end up with r squared minus 12r, because 12 times 1/2 would get us back to 6. Then we'll follow the same steps that we followed in our previous example. We'll find the perfect square in factored form, and then we'll find the perfect square in standard form. So remember that to find the perfect square in factored form, and I'm going to work in a different color so you know that we're not talking about this equation quite yet, I'm going to want to look at my b term, which is negative 12. Half of negative 12 is negative 6, so I'll end up with r minus 6 times r minus 6, which is of course equal to r minus 6 squared. Then I want to convert my perfect square in factored form to my perfect square in standard form. And I end up with r squared from r times r minus 6r minus 6r again, and plus 36, which I can simplify by combining like terms to r squared minus 12r plus 36. Now, let's go back to our original equation, because we have our perfect square in standard form and in factored form, and remember that these two expressions are equivalent. I'm just going to write equiv for short. I have 1/2 parentheses r squared minus 12r equals 2. But I want to include my perfect square in factored form, r squared minus 12r plus 36, in my original expression. So I'm going to go ahead and add in a 36. Notice that when I add in this 36, I'm really adding in 1/2 times 36, because there's this coefficient 1/2 outside my parentheses. If you in your head think what's 1/2 of 36, you might notice that 1/2 of 36 is 18, which is the number that you'll need to add to the other side to make this equation equal. Again, we added 18 to the right because when I added 36, I was really adding half of 36, since there's a 1/2 outside the parentheses. At this point, I have my perfect square included in my expression, so I can convert it to factored form. R minus 6 squared times 1/2 equals 2 plus 18, which is of course 20. Now we're ready to simplify because we're looking for r. Your first step is to multiply both sides of the equation times 2, because that will cancel out your 1/2. If I multiply both sides times 2, I end up with r minus 6 squared equals 40. I'm going to stop there because you should be able to use my example from question 5 to help you find r at this point. You're following the exact same steps as we did in question 5. I'll go ahead and start one more problem. We're going to look at question 7. In 7, we have 2p squared plus 8p equals 7. So just like in question 6, we have a coefficient on our a term, so we'll want to factor out the 2 for 2p squared plus 4p equals 7. And then I'll want to go ahead and find my perfect square in factored form. And my perfect square in standard form. So in this case, my b term is 4, which means my binomial will be p plus 2 times p plus 2, because 2 is half of 4. And of course, p plus 2 times p plus 2 is equal to p plus 2 squared. So then I will convert my factored form to standard form, p times 2, p squared plus 2p, and 2 times p, 2 times 2. So we got another 2p, and 2 times 2 is, of course, 4. I'll combine my like terms of 2p and end up with p squared plus 4p plus 4. Okay, so at this point, you are ready to go back to your original expression, 2p squared plus 4p equals 7. Remember, your goal is to include your perfect square in standard form in your original equation. If I add 4 to the left side, I'm really adding 8 because I'm adding 2 times 4. If I add 8 to the left, I need to add 8 to the right. At this point, you're ready to include your perfect square in factored form in your original equation and solve for p. That's where I'll leave off for question 7. Go ahead and give it a try. The last thing I want to say is about question 8. Hopefully you feel okay solving it at this point, but I want to note one thing. Question 8 looks like this. 2y squared plus 3y minus 5 equals 4. In all of our other equations, we did not have a c term on the left side of the equation. So you're going to want to move your minus 5 over to the right by adding 5 to both sides of the equation. You'll end up with 2y squared plus 3y equals 9. Then you're ready to get started, just like question 7. Remember that because you have a coefficient on your a term, you're going to need to factor out that 2 before you begin. I hope this video helped you guys get started on questions 5 through 8. As always, let me know if you have further questions.